Hey, so the main goal or point of today's video here is to go over the worksheet pages on the rock cycle that you did last week and then give you a brief introduction to the pages you're going to do today, which is what, 10 through 12. So this was page 7, which we should have had done last week. So it has probably a really good rock cycle on it. So why I say it's pretty good is everything's labeled, even the ones that go through the middle. There's even ones that kind of go backwards or in kind of a little loop. So this one's pretty good if you're taking the quiz on Wednesday and you want to use this. I don't really care, but it's just there. There you have one in your notes as well. So 3 classes of rocks, so you're just the 3 types: metamorphic, igneous, sedimentary. And then looking at different arrows, metamorphic rocks, how a sedimentary can turn into a metamorphic is heat and pressure. Follow the arrow from sediments to sedimentary. How do they become sedimentary rocks? So it mentioned a couple things: deposition and burial. So deposition just means the sediment is deposited, meaning it stops moving. Like if it's in a river and the water is pushing it, if it gets to a lake where the water is not moving as fast, that sand, silt, whatever is moving is going to be deposited, which is known as deposition. Burial means underneath a bunch of stuff, and then they have to be compacted and cemented together, or cemented. Okay. How is magma formed? Rock melts. Magma becomes igneous rock by cooling down. How does igneous rock become metamorphic? Goes through heat and pressure. Not enough heat to melt it, though. How does metamorphic rock become igneous? It has to melt to form magma, and then the magma needs to cool. So that's kind of a 2-step process. How are sediments formed? They're formed through weathering, which is rocks breaking into small pieces. And then which process can't happen is D. And the issue is if sedimentary rock melted and then solidified, it wouldn't form a metamorphic, it would form an igneous. So that's really the issue there. And then, can an igneous rock become another igneous rock? Definitely can. That was that loop I was talking about. That rock can melt and then solidify again. Or you could have a much longer journey. You could go around the whole entire thing. It could become sediments, then it could become a sedimentary rock, then it could become metamorphic, then it could melt, then it could be an igneous rock again. So there's lots of different paths that these rocks can take to go from one to another. That's not what I meant to do. There we go. Sedimentary rock. What's one other more indirect way that a sedimentary become an igneous? So it can become a metamorphic first through heat and pressure, and then it'll melt and solidify. So it just has that extra step of becoming a metamorphic first. And then according to the rock cycle, how long does it take for any of these things to happen? The rock cycle, sadly, does not tell you a time frame at all. So it could be a few hours, especially like for extrusive igneous, where it like magma touches water and cools very quickly, or it can take millions of years. So the big thing here is the rock cycle doesn't tell us time. It just tells us the processes that form different rocks. And that brings us to the last worksheet from last week, page 9. There's some that I added a little bit of notes to here, and I'll explain those. But otherwise, take a look at the fact that parallel bands of dark and light is metamorphic or layers. When sediments compress, obviously sedimentary. If it has foliation, which is the fancy schmancy word for layers, is metamorphic. Contains these two here. I had to Google when I did this. Technically, it was in my notes that we did this week too, after you did these worksheets. I'm not super concerned about these ones. So low density minerals are the ones that make them felsic, the igneous rocks felsic, and lighter colored. Olivine is the one that tends to make them higher density and darker in color. So those are both technically igneous, but like I said, don't worry too much about those. Eroded rock, so from layering of eroded rock, which means that it's sediments that have been moved in somewhere else, so that's sedimentary. Then these ones that had specific names, I looked up on my mineral ID chart, or actually I guess my rock ID chart, and gneiss is metamorphic. Limestone is sedimentary. Formed from magma, definitely igneous. Results from cementation of sediment is sedimentary. Forms from molten rock cooling is igneous. This one was more of a think about it question. What's up? Okay, well then you can play it. I'm doing a video and working. Go. Okay, I had to think about number 12 a little bit because it's not necessarily on the ID chart. It's not on our notes. It's more of kind of a logic thinking through this question. So if we take a look at, if we take a look at the rock cycle, sedimentary rocks form from sediments, igneous rock form from magma. The only one that forms from, I think they worded it pre-existing rock, is metamorphic because it could be an igneous rock going through heat and pressure or a sedimentary rock going through heat and pressure, or another metamorphic rock going through more heat and pressure. So metamorphic is the only one that starts from a rock that's already existing, that already is around. Otherwise, sedimentary has to come from sediments first, and igneous comes from magma first, which are sediments and magma are not rocks. Okay, so that brings us to 13. Forms when from dissolved minerals that crystallize between grains. So that's literally describing the process of cementation, like limestone working its way into a bunch of sand that's dissolved in water. And that holds those sand grains together. Marble is metamorphic, forms from lava is A, forms when sediment is transported and then compressed is sedimentary, shows a pattern of layering is metamorphic, and forms when tiny crystals in magma form is igneous. Okay, so those are the answers and a little bit of explanation for some of those. We go to page 10 here, which is a little wonky on my screen. Where you're going to get most of this information from is our notes or the rock ID chart, which is, and if I pull that up actually, okay, so obviously not using the minerals, but some of this information you can get like for the sedimentary page, which is page 10. Take a look at this information and obviously possibly this information here. Like the first question asks, how do we, what are the 3 ways that we can classify an igneous rock? So this literally breaks it down into how it's classified. They say 3 ways. Technically, I think we only talked about 2 ways. The other way, in my mind, is like the rocks that float, the scoria and the pumice. So, or what they call here, the very fast cooling. They all have, bubbles, or they're glass, like obsidian. Okay. So that's kind of the third way there. The other way is on there, or some of the questions you're going to get from your notes, like where do extrusive and intrusive rock form? How fast do they cool? Those are from our notes. Explaining why crystals don't always form when it cools at the speed that it does. Or why does magma cool at a different rate when it's under the ground Talking about some gas, what kind of features might you see in rocks that really quickly cool and they also have a lot of gas in them? The types of crystals, this was the weirdest questions on here. The size of a crystal is probably what I would be looking for on number 10. And then number 11, you can probably get that from this page right here on the igneous rocks. Okay, so that's the igneous rock page. The sedimentary is really just reading some information here and figuring out if that's describing a clastic rock, a biochemical rock, or a chemical rock. So I don't know if did they split that up on here. So you might have to look at some of this information here, possibly. Okay. So this page doesn't have this separated this way, but these ones up here, since they're made up of different sized sediment particles, whether there's like gravel, sand, or clay and silt, which are really tiny particles you can't see with your naked eye at least. These are all examples of plastic rock, which is the fancy name for rocks that are made up of sediments. These two right here, rock salt and gypsum, are chemical rocks. They form when the minerals that make them up, like sodium chloride, dissolve from evaporating water, or not dissolve, they are left behind when water evaporates. And then this stuff down here, plus coal. Coal is just a bunch of plant pieces, like fossilized plants, essentially, kind of, that turn into a different form of carbon, aka coal. All these limestones and coquinas down here are made up of seashells and things like that. So these, the coal and this whole group down here, are the biochemical rocks. So it doesn't say that on this sheet. That might be something that I add in the future, actually. But we've got our clastic rocks, our chemical rocks, and then coal, plus the ones down on the bottom here that react with HCl are my biochemical. Okay, so if we go back to this then, so you're going to use some of your notes on these three different types of rocks here. Some of them, there's a chart down there. Yes. Okay, some of them they give you names, so you just have to go here and look at the categories and what I just talked about. Whoops. Some of them you have to know, like if it says water is flowing through places, you got to figure out which one had to do with water or which one had to do with animal hard parts and things like that. Classified by size and shape, so you look at that ID chart and see which one has, like, if it's this big, it's this kind of rock. If it's less than that size, it's this kind of rock. Okay. Probably have to Google the Latin word, although there's only really one funky word that you've probably never heard of before, so that probably is it. So that's the sedimentary rock worksheet page here. Just writing down which group of sedimentary rock that those sentences describe. Then the metamorphic. It's probably going to be the weirdest and the goofiest. What you can do though, let me hear, is you can like write down next to each of these lines is a different sentence. So it can go A, B, C, all the way down to whatever you're going to get to. And then you can just write one goes with, if it goes with A, then you write A there. If it goes with B, then you write B here. But let's take a look at what some of these are here. So some of these categories, we have metamorphic. There's 3 sentences above that go with all metamorphic rocks. So to me, that would be something like heat and pressure. So where's the one that talks about or classified by texture and rock composition? Right? Yes. So that applies to all of these rocks, regardless of what kind they are. So I put C there. So then you would find the other two ones that have to do with all metamorphic rocks, and it might come down to a little bit of process of elimination. So to me, regional metamorphism means large areas of rocks that are undergoing these metamorphic changes. So there's some up here that talk about happens over a big area or changes a lot of rocks at one time, things like that. But we're going to go in for your regional metamorphism. And then we want to remember what the difference between foliated and non-foliated rocks are. So foliated, if you see anything that talks about layers, or striations is another word for layers, or stacks of things, you're going to be talking about foliated rock. If you see stuff that mentions no pattern in the crystals or things like that, or what are some of the other ones that I'm seeing here? That the crystals kind of interlock with each other in a different way every time. Okay, and then there's some that apply to just the metamorphic rocks. Sorry, I'm trying to figure out ways to do this without just giving you the answers, and it's kind of difficult. So, if some of this stuff is a little goofy for you and you spend more than 15 minutes on this page, just leave it at what you have done and we'll call it good. The other two are a little bit more straightforward. Okay, this one's a little bit goofy. It did go with the textbook I used to have when I taught 8th grade in North Dakota for earth science. So that probably would help out a little bit if we had that, but we don't. So give it a shot. Just pick out what goes with each of these categories, and then you're done with the rock stuff. And the only thing that we really have to do after this is a rock cycle and rock type quiz, is what we're going to do on Wednesday this week. So with that, good luck. Don't, oh yeah, I actually did put C there. C was correct. Sorry, I was just about to tell you to not put C there because it wasn't correct. Otherwise, see you around.